Good morning. Today we're going to study section 6.4, specifically about radians. If we're going to take degrees and put them in terms of radians, take the hint. Multiply by pi over 180, which is like multiplying by 1. Pi over 180, cross cancel, and you wind up with pi over 6. If we take the second question, 60 degrees, again, multiply by pi over 180. Cross cancel, and we get pi over 3. Third example, 180 times pi over 180 . And we're left with pi. If we take 360 pi over 180, we're left with 2, as in 2 pi, which is the same as going around in one whole circle. For the last one, let's think about the coterminality. If I take negative 135 and I add 360 to it, I will get an answer of 225 degrees. Now let's multiply that by pi over 180, and we get an answer that cross cancels. Dividing both by 45, I get 5 for the top and 4 for the bottom, so my answer is 5 pi over 4. Going in the other direction, take a second and pause. We're given the radians. We've got to go to degrees. So now we're going to flip that ratio, which still equals 1, but we're going to multiply by 180 over pi. So if I take 2 pi over 3 and I multiply it by 180 over pi, once again, we cross cancel. The pi's will cancel. I get 60 on the top for an answer of 2 times 60 of 120. Second question. 180 over pi will help convert me from radians back to degrees. The pi's divided by themselves give you 1. 180 divided by 6 is 3. And my answer, 7 times 3 is 210 degrees. Last one, negative degree going in the clockwise direction. Process remains the same. 180 over pi, cancel. Pi divided by pi is 1. 180 divided by 3 is going to give you 60. Seeing what's left, a negative and a 60 is in fact my answer. Picking up another piece of the puzzle, seemingly, for now, let's go back to the concept of coterminality, but we're going to do this in radians before we put the ideas back together. Since we know that every circle of 360 degrees is the same as a circle with radians in 2 pi, per the other examples, if I'm going to solve coterminality, I'm just going to subtract 2 pi every time. So my first one is 1 pi. And just like when we were doing coterminality with negative angles, you would add 360. So now we're going to add the 2 pi. Negative 5 pi plus 2 pi would give me negative 3 pi. So do it again. And you get negative 1 pi. For my next example, I have a fraction. It would already be in a position of within the original unit circle, but to work with fractions in practice using coterminality, I could choose to either take my 2 pi over 3 and subtract 2 pi, or I could add 2 pi, because again, I'm only finding what's it coterminal with. I'm going to go with add because I'm feeling positive today, and I need a common denominator, so I'm going to multiply by 3 on the denominator here and 3 on the numerator here, giving me 6 pi over 3, also known as 8 pi over 3. And then last but not least, 11 pi over 4, add 2 pi or subtract 2 pi. It's up to you. Both will be coterminal. Still need a common denominator. So I'm going to multiply the denominator by 4 and then its numerator by 4 to get 8 pi over 4 for an answer of 3 pi over 4. As established in class, I prefer degrees to radians. So when I'm asked to find cosine with respect to radians, I'm going to take a moment, convert it into degrees. So I'm really looking to find the cosine of negative 60 degrees. What does that look like? Negative 60 would go here. Then I would use my right triangle relationships. Across from the 60, I'm always going to have radical 3. That one happens to go below the axis, so it's negative. Using the rest of your triangle relationships, this would be the right angle, so this would be the hypotenuse of 2. And then finally, you have a 30-degree angle and a side of 1. Using what we know about cosine, I would do cosine of negative 60. So there's my negative 60 going in the clockwise direction. Reference angle is 60, hence my triangle that you see. We're going to go adjacent, which is positive 1, over 2. And if you remember the ratios of all students take calculus, cosine in the fourth quadrant will in fact be positive. So I have the right answer at positive 1/2. For my second example, again, I'm going to take 11 pi over 4 and convert it to degrees. I wind up with 495 degrees. So now I've got to bring in the concept of coterminality. So subtract 360 and you're left with a 135 degree angle. Draw it out. It would be here, leaving me with a reference angle, 180 degrees. Take away 135, and you're left with the reference angle of 45. If the reference angle is 45, then the side lengths for a 45, 45, 90-degree triangle are 1, 1, and radical 2. Be careful with what quadrant we're in. We're in quadrant 2, so the x-coordinate is going to be negative. So I'm really looking for the tangent of 135, which is the same thing as a reference angle of 45 for tangent, which is 1 over negative 1, because we're in the second quadrant. Answer, negative 1. Sine over 2 pi over 3, convert, cancel, 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 and I'm left with a 120 degree angle. What does that look like? Similar to the picture above, except that the angle is 120, which makes the reference angle coming down to the x-axis 180 degrees for a straight line. Take away the 120 you've used, giving you a 60-degree reference angle. Always across from a 60 degree is the radical 3. Here's your right angle, a hypotenuse of 2, and Pythagorean theorem would say this is 1. Again, because we're in quadrant 2, from the x-axis going backward to the point of the reference would be negative 1. So I'm really finding the sine of 60 in quadrant 2, which is the same as sine of 120. And I'm going to get sine, which is opposite over hypotenuse. All students take calculus. Students is in quadrant 2, so sine in quadrant 2 is positive. The last one is a little trickier because now we're dealing with radians that need to be converted, and we're dealing with cosecant. One piece at a time, let's convert. So I'm dealing with a 135-degree angle. Remember that cosecant starts with a C, goes with the opposite function, meaning goes with the sine function. So I'm going to find the sine of 135, which is a 45-degree reference angle. Ratio is 1, 1, and radical 2. The 1 on the x-axis will be negative. All students, so sine is positive. Take calculus. I will be dealing with the sine, which is opposite of cosecant. It's reciprocal, which would be 1 over radical 2. That would be the sine function. Rather than rationalizing and then derationalizing, I'm going to work with the concept of sine being the reciprocal of cosecant, and I'm just going to make this its own reciprocal so that the cosecant of 135 is going to be radical 2 over 1. Happy computing!